Hey guys, today we are going to talk about sequences, which is a specific rule that you follow that will give you a set of numbers that have a pattern based on that sequence, which is very similar to functions that we've been talking about. It's just a different way to look at them and write them and find information. So first I want to talk about just sequences in general. What is a sequence? I'm going to upload a copy of this to the daily assignment today, and you'll work on the rest of them, but we are going to do one together, and then we're going to go to the notes and fill those out. If you are able to print those, there's really, I think, 3 things for you to write down on the page, and then you're done, and you don't have to write anything else. So the notes today are super short because most of it is typed. But I am going to want you to do the rest of this worksheet on your own today. So let's look at sequences. So we are going to annotate them a little bit differently. Instead of writing y equals 2x minus 2 or f of x equals 2x minus 2, we have a sub n equals 2n minus 2. So the a sub n is just a way to write any number in this rule. A being the rule, n being any number that you want it to be. So you can change that n value to figure out which specific number you're talking about. So if I say a sub 1, that means for this rule, which is right here, this rule, 2n minus 2, the first number in the sequence is 0. Okay, so this is information that I need, and I'm going to come over here and fill my table out with that information. So if the n, just the n, this little n that's behind the a right here, the n stands for the term number. So the first number in this sequence is 0. It told me that right here. If the first number is 0, what is the second number? So what you're going to do is take 2 and plug it into this function. So the n is what gets plugged into the equation. Whereas before when we had f of x and we plugged the x in, now we plug in whatever the n value is. So if I want 2, this is my rule, and I'm trying to find the second term, I'm going to plug 2 in right here. Well, 2 times 2 is 4, minus 2 is 2. So the second term in the sequence is 2. What about the third term in the sequence? If this is my rule, and I plug in 3 into the rule, well, 6 minus 2 is 4. What about 4? What is the fourth term in this sequence? Well, I've got to follow my rule. I'm going to plug 4 in. 2 times 4 is 8. Minus 2 is 6. And 5. What is the fifth term in this sequence? So if the sequence rule is 2n minus 2, I'll put 5 in as the term number, and it'll tell me what it is. 2 times 5 is 10, minus 2 is 8. So the sequence, with the first number being 0, the next number being 2, the next number being 4, the next number being 6, and the next number being 8. This is the sequence you get when you follow this rule. And I did it in a table over here just to help me see. So if they tell me what the first term is, then I know how to start, and I just follow the rule. So if I were to plug 1 in here, 2 times 1 is 2, minus 2 is 0. So that's how the first term got to be 0. They told me that, and it works when you plug it into the rule. So you take those n values and you plug them into the equation. They're like your inputs. And the answers you get are your outputs. So these are the inputs that we plugged into the rule. The answers are our outputs. Whereas in sequences, the n value is the term spot. So O is a sub 1, or 0 is a sub 1, sorry. 2 is a sub 2. 4 is a sub 3. 6 is a sub 4, and 8 is a sub 5. That's the first term, that's the second term, that's the third term, that's the fourth term, and that's the fifth term. It can get a little confusing because as we're talking about the placement of the number, it doesn't always match the number. So it's strange to say that 4 is third, because 4 seems like the fourth number, but it's in the third spot. 6 is fourth, not 4, because 6 is in the fourth spot. So those A sub numbers stand for the placement. And then the actual output, when you plug it into the rule and find the answer, that is the actual term number that's sitting in that spot. And this applies for any sequence. We can make a crazy rule or a not so crazy rule. So number 2 is going to be your rule that you follow is n divided by 2. So whatever your n value is, you divide it by 2. And your first number is 1/2. Okay, so you can come over here just like I did before and make yourself a table. And they told you what the first term was. It's 1/2. 2, 3, 4, 5. And I want you to find the first 5 terms of every sequence. So what you're going to do is take these numbers, plug them into your rule, and get an answer. These numbers into the rule, get an answer for every single one of these, and write your sequence. 1, 2, 3, 4, 5. And I'll give you 2 more that you'll do on your own. So you'll have this one and 2 more to do on your own. And this is the example that you can go back to and watch in this video on how we solved this sequence and what it was telling us. So it's very similar to what functions are. It's just a new way to write it and a new way of looking at things. So let's look at our notes for today. They're super simple. If you have a way to print these out, even better. If not, you can pause the video and copy it down. Arithmetic sequences. So an arithmetic sequence is a sequence where the difference from one number to the next number is a common difference. It doesn't change. It's always the same. So in our sequence list here, from 6 to 11, there's a difference of 5. From 11 to 16, there's a difference of 5. And from 16 to 21, there's a difference of 5. So they all have a common difference. And you can start wherever you want in the sequence, but wherever you start, that first number is A sub 1. So it's notated A with a little 1. You say A sub 1. You can start wherever, but that just tells you the spot. So 6 is first, 11 is second, then 16 is third, then 21 is fourth. So each number has a location in the list. You can come up with these yourself. I always start with 1. So they chose to start here. This is the first number, second, third, fourth. So an arithmetic sequence, the actual definition, it's an ordered list of numbers such that the difference between the consecutive terms is constant. And we saw that above. The difference was the same every time. And then it says understanding subnotation. So we think of an arithmetic sequence as one big list. We use the variable a to stand for all the numbers in the list, and then we use the subnotation, that small number to the right, to tell us the position of the number in that list. So a sub 1 is the first number, a sub 2 is the second, a sub 3 is the third, and a sub 10 is the 10th, so on and so forth. But if you want to just write the rule that you can use for any number and you don't want to give a specific number, you write a sub n. N is just a variable, it's just a letter. So that means that we're talking about any number right now. Unless they tell us a specific number for n, we don't put a number there. And we just write it a sub n equals whatever the rule is that we follow. They can then take that rule that's able to be used for any number and apply specific numbers to it, which is exactly what we did here. So our rule is right here. This is the function rule for any number. That's why we left it as a sub n. Any number can use this rule, 2n minus 2. Now, to find the first number, a sub 1, we plugged 1 in into the n, and we got 0. So we plug it into the equation, and we get the answer. And the output is the actual number in that spot. And so you're going to continue to do that today, working on just sequences in general. They don't have to follow a certain rule. We're going to get tomorrow into specifically explicit and recursive arithmetic sequences, which is where every single time your rule is being added or subtracted by a specific amount, but there's two distinct ways to write them. So just getting used to sequence notation and just what these numbers and terms stand for and how we do them and use them. And tomorrow we'll get into a little bit of the more meaty stuff, and it'll be a little bit harder. But good luck on your notes today and on your worksheets.